Thank you for coming to my talk. My name's Parker. If you don't know me, I support the engineering practice at Labs, Pivotal Labs. I'm here to talk about Agile Architecture. And I know that, one, it's lunchtime and you're all hungry, so thanks for coming anyways. I promise I will try to distract you from the hunger. I don't know if I can promise more than that, but at least I'll try to do that. Agile architecture is an interesting topic because there are a number of people both within and without the Agile community that aren't convinced that these two topics go together. They're concerned that these two topics are in conflict, that somehow the goal of the Agile software development movement is to eliminate architecture, and the goal of the architecture movement is to somehow wrestle with the Agile software engineers. So I think at heart, there is a more fundamental problem that's causing all of this, and it really boils down to this question: what is architecture? This is a great question. I highly encourage you all to go around and ask people at this conference, what is architecture? Architecture is a word that's probably going to be used thousands of times over the next several days. But if you go around and ask people what it means to them, you'll find many different answers. And some of them will be complementary answers, some of them will just be different, and some will be contradictory, and some won't necessarily come from a good place. So I have asked lots of people this question. One time, I even had 20 people join me in a room, and they all sat down, and they all had a piece of paper in front of them, and I asked them this question: what is architecture? And everyone wrote down what they felt like the answer was on a piece of paper, and then they passed the paper to the right, and the next person read it and said, oh, no, that's wrong, and they wrote down their answer, or argued with it, and then they passed the paper to the right. By the way, as an aside, that's a cool facilitation technique. If you're ever in a situation where you need a bunch of people to discuss something, and you know that none of them agree on it, and you're wondering how can you make sure everyone's voice is heard, the paper passing game is a fun way to do that. Anyways, what I ended up with were 20 different definitions of architecture. Let me share some of those with you now. Brace yourself. So one person said, it's what you worry about when it's not your responsibility to worry about delivering software. Okay, I feel like that answer is a little bit cynical. Maybe they've been burned a bit in the past by architecture somehow, or their understanding of it. Another person said, it's a set of training wheels for developers who don't know how to apply the solid principles in practice. Okay, so pro tip, anytime somebody uses training wheels in a definition of something, it's not coming from a good place. They're not flattering. Like, it's not, there's nothing good about that. Another person said it's how vendors make money. I also think this definition is maybe a bit cynical. It may also be true, but it's also, I don't know that it's coming from a good place. Another person said architecture is BDUF. If you don't know what BDUF means big design up front. And this person that wrote this was likely a proponent of Agile software development, because BDUF is very common in waterfall software development. And many Agile software developers have kind of set out to end the tyranny of BDUF. And so by equating architecture with BDUF, I don't think they like architecture. Another person said UML. That's what architecture is. It's UML, Unified Modeling Language. And OK, so the question, what is architecture? There is no consistent answer in our industry. But if you go around and ask people, do you like UML? You get a pretty consistent answer. The answer is pretty consistently no. So I don't think this person liked architecture. And that makes me sad, because UML is actually a great tool that you can use for profit. But it's not necessarily looked upon favorably by and large in our industry. OK, so you get all kinds of interesting answers. Some people don't know, and they're kind of questioning. Like, so I've gotten answers like, is it Spring? Is Spring the architecture? And that's kind of an interesting idea, right? Like, maybe we're beyond architecture now. Maybe frameworks have solved architecture for us. We don't have to talk about it anymore. Other people are very convinced it's microservices. And end of story, we don't have to talk about architecture anymore either. So this is really weird. We have this word that we all use all the time, and we don't know what it means. We don't agree upon what it means anyways. It means so many different things to so many different people. So what the heck is architecture? OK, there are thought leaders in our industry that are doing a lot right now to promote, I think, a much more consistent answer to this question. And if you look like, so people like Simon Brown, people like Matt Stein, who I think is just a few conference rooms away giving a talk on architecture, Martin Fowler, and on. There are several people that are starting to align on an answer to this question. And if you look at where their answers came from, they all tend to trace back to him. His name is Grady Booch. Has anyone here ever heard of Grady Booch? Okay, so several of you have heard of Grady Booch. Grady Booch is someone who's been in our industry for quite a while. He's been incredibly influential in the field of software development and the field of software architecture. He created something called the Booch method back in the early 90s, which was a precursor to UML. And it was one of the things that led to the creation of UML, and he worked on UML with other people that were creating similar methods. Today, he lives in Hawaii. He's a super cool dude. He lives in Hawaii. He's a fellow at IBM, and he's a world-renowned expert on artificial intelligence. But he said some pretty amazing things about architecture, which people have started to resurface. For instance, if you check out these books by Simon Brown, Software Architecture for Developers, you can read some of Grady Booch's original writings on architecture. And they're quite profound. And so I want to share some of them with you to start to arrive at a more unified definition of architecture, generally speaking. One of the things that Grady said was, all architecture is design, but not all design is architecture, which I think is really interesting. It's starting to point that there's a spectrum of activities here between design and architecture. But what does that mean really? Well, he also said something more specific. He said, architecture represents the significant design decisions that shape a system where significance is measured by cost of change. And Simon Brown, in interpreting all of this, he's basically said, well, what Booch is really saying is that significant decisions are architecture. Everything else is design. And I think we can all start to simplify that even further to simply say that architecture in the field of software development are decisions that are hard to reverse. And I think with that definition, decisions that are hard to reverse, every single person in this audience, regardless of whether or not you were for or against architecture walking into this door, have to recognize that you do architecture as a software developer. Has anyone here ever written a program? Okay, you've all written a program. Then you do architecture because guess what? When you write a program, you do it in something called a programming language. And that programming language is hard to reverse. You may have decided at the beginning, like, I'm going to do this in Golang. And 3 months later, you decide, you know what? I wish I hadn't done this in Go. I wish I'd done this in Java. Well, good luck. Like, you're 3 months in. You're not going to reverse that decision instantly. The language, the programming language itself, is an example of an architectural decision. OK, now with that definition, you can start to imagine all kinds of different categories of architecture. They could break down in a number of different ways, some of which I know something about, most of which I know nothing about. But let's look at some of them. So software architecture. So the kind of decisions that you make in and around the code that are hard to reverse. Hardware architecture, right? You can make decisions about the hardware supporting the software development that's hard to reverse. You could do the same thing with the network. You could do the same thing with data and where you house data and warehouse data and store data and how it's configured, all that kind of stuff. Like, and on, security infrastructure, et cetera. There's tons of categories of architecture out there. The only one that I feel in any way, shape, or form competent to talk about is software architecture. And what I really just mean is decisions we're making in the code, because that's all I've really done in my career. I've done a lot of code, and I've made a lot of decisions, many of which were hard to reverse, many of which I made unknowingly and only felt the pain of later. And so I feel it incumbent upon me to help everyone understand this better, so that you don't have to experience all the same pain I did. OK, so then what is software architecture? Again, this is not a definition I made up. The first time I read it, I didn't quite understand what it meant, but it did strike me as profound. And once I understood it, I realized how profound it really was. So it's a three-part definition. Software architecture is the high-level structure and flow of the code. It's independent of the problem domain, but it's dependent on the desired user experience. OK, so the first time I read that, I really didn't know what that meant. I was quite confused by it. But I think I can make this very simple and kind of meaningful through a few examples. Let's look at 3 common types of software architecture and how they conform to this definition to make this definition make sense. Those 3 common types, and there are many other types, by the way. These are just 3 common ones that you've likely dealt with in your career. One of them is called request response. Another is called event-driven. And another is called batch. So let's look at each of these in turn with some examples to see what this definition really means. OK, this probably looks familiar. It's a login form. You've probably all used one. In fact, who here builds web applications and builds things like this? OK, so many of you have actually built code that makes this kind of thing. So think about the user experience for a second. It's very much a conversation between you and the system. It doesn't matter what anyone else is doing and how they're interacting with the system. This is your conversation with the system. You come to the system and you say, I would like to log in. Here's my username and password. And you submit a request. That is your request to the system. And you get some kind of response like, hey, great, you're logged in. Or, sorry, that was the wrong username and password. No. That's a simple request response flow. But it's not just web applications that have that kind of user experience. It's also command line applications. Who here uses the command line? In fact, I bet many of you have built command line applications, right? No one? OK, never mind then. One person. One person's done it. 2, 3. OK, great. Some of you even built these command line applications. So imagine going to the terminal and typing ls, and maybe you pass some options to it, like show me everything and tell me which ones are folders, and you hit enter. Well, you just submitted a request to the system, and you got a response. Right? Here on standard out, you got a response that told you everything that's in your current working directory. OK, so these are clearly, these two examples very clearly have different delivery mechanisms. Right? One is delivered through a browser. The other is delivered through a terminal. They have very different problem domains. They also have the same user experience fundamentally. There's not really any difference between those user experiences. They are both characterized by a conversation that involves a start-stop request-response flow. And fundamentally, behind the scenes, when you peel back the code and look at the code behind ls and look at the code behind that web application, it's the same. It's not actually different. As much as we probably want to believe that they're different, they're not. They have the same high-level shape and flow because it was independent of the problem domain, but dependent on the desired user experience. OK, let's look at some other examples. So will anyone here admit to playing games like this? Cool. I admit to it. And think about this user experience for a second. This is obviously very different from filling out a form or typing a command in a terminal. Right? You are one of many actors in the system, all acting independently. Based on everyone's actions, you're either responding to or ignoring to those kind of events that are created through this process. Right? Maybe you and another player collide into each other. That collision event is registered by the sound engine. The sound engine makes a noise. The physics engine does something. The points engine deducts points from you or whatever. Right? Like, there's all kinds of interesting stuff happen. It's not based on you and the system. It's based on you and everyone else interacting together through the system. And that leads to a profoundly different software architecture. Has anyone heard of this thing, Pivotal Cloud Foundry? It's pretty cool. I like it. And actually, what's fascinating about it is behind the scenes, the core distributed system behind it, Diego, is event-driven. Because there's just a whole world of things that happen behind the scenes. Apps are getting spun up. People are tripping over cables in data centers, taking down entire servers. Therefore, Diego needs to be able to respond to that, spin up apps in a new place. A bunch of traffic suddenly comes in. The autoscaler registers that and scales up more instances. Right? Like, there's just this fascinating world of things happening with both human and non-human actors. And it's not a single start-stop request-response flow. It's event-driven. In fact, even though these two examples have very different delivery mechanisms and very different problem domains, they actually fundamentally have the same software architecture. Diego is like a game. And the game is like Diego. And that's really fascinating to me. OK, so we looked at event-driven. We looked at request-response. We haven't looked at batch yet. So you probably get one of these every 2 weeks. It's a paycheck, right? But you know how every 2 weeks to get that paycheck, you have to log onto the website, go to the form that says, please pay me, press the button. Otherwise, you're not going to get paid, right? No, that's not how it works? OK, you're right. That's not how it works, because you don't have to make a request, but you still get a response. Right? And that's one interesting characteristic of batch software systems. It's what happens when you remove the humans from the request. When the humans are no longer there to make requests, but humans still need responses, you end up with batch software architecture, where the system simulates the requests on your behalf. And not only simulates the requests on your behalf, but deals with failure. Right? Because imagine, go back to the login form. Like, imagine you filled in that login form, and you press submit. And instead of getting a response like, great, you logged in, or you didn't give me the right username and password, imagine you got a response that was more like 503, service unavailable. Right? Some kind of temporary transient failure. You as a human can deal with that. Right? What do? You just click refresh, right? You just go and click refresh. But now imagine behind the scenes, batch software, doing payroll, some kind of transient failure happens. There's no human there to click refresh, right? Because there's no human there making the request. The system has to be able to handle that. And that's what makes batch software architecture fundamentally different from the others. Okay, there's many more other types of architecture, most of which I know nothing about. Okay, so the question then becomes, well, when do Agile engineers architect the software? Do we determine it all up front? Does it evolve over time? Does it emerge naturally through refactoring? Well, to answer this question, we can think about it in one certain way. There's something else that Agile software engineers do. Most of them do something called test-driven development. They go to write a test. But before they can actually write a test, they have to know the architecture within which they are going to test. Like if you don't know, like fundamentally, like, oh, I'm going to go build some behavior, but I don't know if it's event-driven. I don't know if it's request response. I don't know if it's batch. Who knows? Oh, we'll just figure it out along the way. It's probably not going to work out very well. If you just guess and you get it wrong, that's also not going to work out very well, right? Your tests are architecture aware, just as all your code is. So TDD can't begin until you know the architecture within which you will TDD. That means that architecture happens before development. And maybe that sounds blasphemous to somebody that's very into Agile because I'm saying you have to do some work up front before you can start software development, but it's actually very necessary. The other thing, though, is that remember how the software architecture depends on the desired user experience? Well, if you're doing Agile software development, the user stories are where you go to find the desired user experience, but you don't know them all up front. It's not like you planned out thousands of user stories all up front, years worth of work, and then just went off into a cave and built it all. That's not Agile software development. Right? You started with an idea, you built some stories, you put them in front of people, you gauged their response, and then you improved the software based on that. You iterated day over day over day by continuously putting software in the hands of users. Okay, well that means that you don't know the software architecture up front, at least not all of it. You don't know what's going to happen. That means architecture also has to happen during development, and so maybe that sounds a little bit contradictory that it's happening before and during, so let's just look at an example. Okay, all right, imagine you're on an Agile software development team, you show up to work, you all stand around in a circle and do a stand-up, and one of the things you do is you decide on who's going to pair with who because you're all going to do pair programming because you're super into Agile, and then you sit down and you start to pair program with each other, and well, what's the first thing you do? Well, first you type command spacebar and you type CHROME because that's the coolest way to open Chrome, and then after you open Chrome, you go open a pivotal tracker, and inside tracker, you find a backlog, it's your backlog, and without thinking, without doing anything else, you immediately click start on the top story because that's what you do when you do Agile software development. You pull from the top of the backlog because you know it's the highest priority thing. You start it, but then you have to say, okay, well, what is this story really? You look at the story description, and then you stop. You say, okay, well, based on this story description, let's have a conversation. Because we can't begin to actually implement this story until we know the software architecture that this story demands. And you're going to have either you're going to end up with one of a few answers. One, I know exactly what kind of user experience this story is demanding, and I know what kind of software architecture maps to that user experience. My pair understands it too. Boom, we're done. We're going to go. Maybe even you just knew it implicitly and you didn't really even have to have a conversation. Or maybe you look at it and say, I don't feel like there's enough information in the story for me to even understand what kind of user experience this requires. Well, good news is you're on a co-located Agile team. You just turn around to your product managers and designers and ask them, like, wait, we need more information. What is this? Or there's a third option in which it's very clear what kind of user experience it's calling for. It's also very clear that you've never built that before and you have no idea what kind of software architecture is required for it. That's a really great moment to also celebrate the fact that you're on a co-located team and you turn around to everyone else and say, somebody help, because we don't know what we're doing anymore. Okay, but eventually maybe you decide, oh, this is a request response user experience, and then you can actually start writing a test where you go describe some behavior and you exercise some requests and assert on some response, the easy stuff, right? Okay, that in a nutshell describes when software architecture is happening, right? It's not all happening up front, it's sort of happening just in time. You're pulling up a story, it's the next highest priority thing. You don't know what's going to come next after this because priorities might change based on user feedback, but based on this story, you can make a decision. And what this really means is that your application that you're building probably won't just have one software architecture. It'll have many. Many software architectures will be housed within the same product. And I think that's good to know because the reality is that I think I've certainly seen a lot of people try to force everything in their application to have a single architecture. Despite the fact that that's often like the square peg in the round hole. It doesn't always make sense. Sometimes you need multiple architectures to exist simultaneously, and that's our job to manage that complexity as developers. Anyways, but because this could happen at any moment you could be presented with a story that requires you to introduce a new architecture into the software that you have yet to use. You need to be ever vigilant. In the words of one of my peers, Mick Friedman, he always reminds people, be ever vigilant, right? Because there's nothing worse than going down the wrong path, choosing the wrong architecture, and then having to unwind all that code because it turns out that architecture was very hard to reverse. OK, there's many more things I could say about Agile software architecture, but for now, I think I'll leave it at this. I know you're all hungry. If you have questions, feel free to come up and ask them. I'll stick around, but thanks for listening.